Okay, day 2, 4.7. Today we're going to work on evaluating compositions with inverse trig functions. Compositions we had back in chapter 1 or 2 is like f composed of g of x, kind of like two functions in one. All right, they just aren't quite written or expressed like that. I'll show you how they're expressed. Okay, we're going to start with example 14 in the notes. Find this. Sine arctan of 4/3. Okay, now the nice thing is I am going to stick with the same success criteria I gave you yesterday. Okay, and then it kind of leads you right to the answer. All right, key is though, we want to start inside the parentheses. Okay, I kind of think it's just order of operations. We want to start here. Inside the parentheses, okay? All right, so then from there, I'm just going to keep this flow chart kind of going here. Let's use that same success criteria from yesterday. Step 1, I had you rewrite with this. Ignore the sign altogether. What does it mean for it to be arctan 4/3? It means we want to find the angle. Tan of what angle gives me 4/3? And then let's recall the restrictions on theta for tangent. Theta has to be greater than negative pi over 2 or less than positive pi over 2. Like that. Okay. All right, so steps 2 and 3 we'll kind of do together. Step 2, which quadrant is this going to be in? So remember, we're right now restricted to only 2 quadrants for tangent. If it's starting at the positive x-axis, it could rotate down to negative pi over 2, not equal to pi over 2, but just before it, and up to positive pi over 2. So first or fourth quadrant. Okay, but by our sign rules, a smart trig class, only cosine's positive down here, meaning tangent's negative, and this is not negative. So it cannot be in the fourth quadrant. So the angle must lie in the first quadrant. Okay, so right now you're thinking, wait a minute, 4/3. Yesterday, these all related to the special right triangles and had angles that we could use. That's not going to always happen for these ones, but that's okay. All right, let's go ahead and finish this sketch, though, before I get too far ahead of myself here in that explanation. So let's drop a reference triangle down, and let's throw these in the right spot. So if I said tangent is 4/3, we should relate the 4 to 3 as opposite over adjacent, or y over x for tangent. Okay, so let's put those in that correct spot opposite angle theta here. So 4, and then this is 3, and we need to go find the hypotenuse. And so here's why we want to find the hypotenuse. Now, we don't really need this angle. Think about it. It's asking for, if we look at the outside of this now, sine of this angle. Let's just say this angle is 22.8 degrees. Okay. Well, then what's the sine of 22.8 degrees? All we need is the triangle to figure that out. So you don't really need to find the angle in these problems. You just want to find a sketch for the scenario to finish it off. All right. So you shouldn't recognize this as a 3, 4, 5 triangle, but if it's not, use Pythagorean's theorem to figure it out. Okay, so the sine of this angle is going to be 4/5. That's the answer to the problem. Okay, so just a quick recap. Yes, inverse trig functions. We're usually looking for the angle for this as the answer to it. But you don't really technically need to find the angle because we're going to find the sine of this angle. And so once we get the sketch going, we can find the sine of this unknown angle. Okay. And the way to find the angle now will be to just throw in our calculator. We get a decimal answer, but you don't need it. All right. All right. Let me show one more on 15, and then I'll have you try 16. Okay. Let's see another one here. Once again, we want to start on the inside. So we're going to rewrite this as sine of what angle gives me negative 5/12. Now, technically, right, we don't really need to find the angle, but if we get a sketch of the angle, then we can find the big picture. What's the cosine of this unknown angle? That's going to be the answer to our problem. Okay, so theta for sine has to be greater than or equal to negative pi over 2 or less than or equal to positive pi over 2. Okay, so that means up to the first quadrant somewhere or down into the fourth quadrant, and it's negative. So it can't be in the first quadrant where they're all positive. So we're here. This is rotating down into the fourth quadrant for sure because of the negative. Let's create a reference triangle with the x-axis. And we're going to use the definition of sine to our advantage. Remember, the reference angle is the angle made with the x-axis. So we should put theta here, not down here. So since sine is opposite over hypotenuse, we should put 5 and 12 here, and then make some sense of where we should put the negative. It's in the coordinate plane. Then we have positive x and negative y. We don't ever make the radius negative, okay? Or hypotenuse. Okay, so now I have a sketch for this. We need to find, don't worry about finding the angle. We need to find the cosine of this angle, and I'm close. Cosine involves adjacent, or the x value, over the hypotenuse. So we need to find that. All right, so we'll do leg squared. I'm going to call it x plus y squared equals the hypotenuse squared. All right, so this is 25. So I need to move this 25 to the other side. And that gives me 144 minus 25, 119. Okay. I'm not making this a negative 25. You guys realize that, right? Negative 5 squared is positive 25, and then I'm subtracting that to the other side, of course. All right, so then we take the square root of both sides, and we get, I don't think there's any square that goes into 119, so we'll just leave it like that. Leave it in radical form. Okay, so we get square root of 119 here, and now we can find the cosine. So cosine of this unknown angle theta is equal to square root of 119 divided by 12. That's the answer. Okay, so pause the video and try number 16. Try this one also has a radical, but you can actually simplify. It's a smaller number, easier to work with, but try to simplify the radical for 16. Okay. All right, so 0 to pi. So we're thinking, all right, maybe in the first quadrant or on to the second quadrant. But cosine's negative in the second quadrant. Only sine is positive here. Cosine's negative, and that is not negative. So we need to put that in the first quadrant, okay? So x over r, find the unknown side y. So 2 square roots of 6 is our unknown side. All right, now that we have the triangle, this is the setup. If you can get here, you're good to go. Can you remember the definition of cosecant? It's the reciprocal of sine. So sine would be O over H. If I flip that over, H over O, like that. And then just rationalize it. Whatever's the radical part in the denominator, multiply it by that. So up top, I get 7 square root of 6. The bottom, think about this. Square root of 6 times square root of 6 is 6 times the 2. So that's the final answer. Okay, last set of problems I want to look at here is 17 and 18. I'll do 17, and then you try 18 to wrap it up. All right, 17, same flow. They threw a variable in there, so it kind of adds a little algebra to this process, okay? So we're still going to start here. Sine of what angle gives me 3x? And there's the restrictions on sine. Okay, so what quadrant is it going to be in? Either first or fourth, but sine's positive. So just the opposite of the problem above. When sine was negative, we put her in the fourth quadrant. This one's positive, so we're going to put her in the first quadrant. Okay, so it's an algebra expression. So I would put this as 3x over 1, so you have something to put on the hypotenuse. So opposite this angle needs to be 3x, and the hypotenuse needs to be 1. Okay, we're asking for the secant of this. The secant does deal with the adjacent side, so we need to go find this. It's just going to end up being an algebra expression. All right. So leg squared plus leg squared equals hypotenuse squared. I usually sometimes call this x, but that has x in it. So I better just call this like a squared, b squared equals c squared. So a squared plus b squared equals the hypotenuse squared, which is 1 squared. Okay. So this is 9x squared. Maybe I'll just clean this up on this step. 3x times 3x. Let's solve for a. So let's move the 9x squared over by subtracting it. Or maybe you write negative 9x squared plus 1. Your call. And then take the square root. So square root both sides, and we get square root of 1 minus 9x squared. Don't try to get too fancy and take the square root of a sum or difference. You can't really do that. So that's this leg. This goes right here. This is the square roots, 1 minus 9x squared. Okay, so again, if they give you an algebra expression, just throw it in there. Just stick to your leg squared plus leg squared equals hypotenuse squared. A couple steps and you have an expression for that side. Now we can find the secant. So the secant of theta will be equal to, remember this is cosine's reciprocal. So cosine, we'd say adjacent over hypotenuse. But I have to flip that over and say hypotenuse over adjacent. Okay, and then just rationalize it and we'll be done. Once again, it might look messy, but it's actually just as easy as doing this on the last problem. When we multiply by square root of 6, square root of 6, there's just more under the radical now. Just multiply it by this. And here's our answer. Up top, I have square root of 1 minus 9x squared. On the bottom, these radicals cancel each other out. That's it. That's your answer. Okay, once you get done cleaning that up, pause and try number 18. One adjustment. Try this with CSE instead of cotangent to force us to find the other side, the missing side. So try it with CSE. All right, so here's what we have. Tan theta is 2 over x, restricted to these quadrants, up to the first, down to the fourth, but it's positive, so it's going to be in the first quadrant. Tangent's negative in the fourth quadrant. All right, so putting this here, leg squared plus leg squared, because we can do this backwards, opposite over adjacent. Pythagorean theorem gives us this, x squared plus 4, take the square root of both sides, and we get this for the hypotenuse. So just put it on the hypotenuse, and now we can answer any question. In this case, I asked you to do cosecants. So cosecant, reciprocal of sine. So we're going to do hypotenuse over opposites. There's the final answer. Okay.